Before we write any code, we need a mental shift. Errors aren't just bugs or mistakes, they are predictable events in an application's lifecycle. Network failures, invalid user input, or a database being temporarily unavailable are not code defects. They are operational possibilities we must anticipate. Embracing this is the foundation of defensive programming, which is especially critical in Node.js. So, why is Node.js unique? It's the non-blocking event loop. When you start an async operation, like a database query, Node doesn't wait. It continues. If an error occurs in that operation's callback, it happens outside the original call stack. With no handler in place, this rogue error has nowhere to go, causing an unhandled exception that crashes the entire process. This brings us to the two fundamental types of errors we must classify. To handle errors effectively, we must first categorize them. Broadly, they fall into two types: programmer errors and operational errors. Programmer errors are bugs, logic flaws, typos, calling an undefined function. These should be fixed in development, not handled in production. Operational errors are runtime issues from external systems. An API is down, a file is missing. These are the errors we must anticipate and manage gracefully. Let's first look at the anatomy of the object that represents these errors. When an error occurs, Node.js gives us an error object packed with debugging information. The name property tells you the error type, like type error. The message is a human-readable description of the problem. And most importantly, the stack property provides a stack trace, a roadmap showing the exact line and function call sequence that led to the error. Understanding this structure is fundamental before we try to catch and handle them. Let's start with the simplest case, synchronous code. The try-catch block is our go-to tool. You place any code that might fail inside the try block. If an error is thrown, execution immediately stops and jumps to the catch block, where you can handle it. This prevents a synchronous error from crashing your application. But what if you need to perform cleanup regardless of whether an error occurred? That's where the finally block comes in. Code inside finally is guaranteed to run after the try block, regardless of the outcome. It runs if the try block completes successfully, and it also runs if an error is caught. This makes it the perfect place for cleanup logic, like closing a file handle or releasing a database connection, ensuring your application doesn't leave resources hanging. Next, let's see how to create our own errors. Sometimes you need to signal an error condition yourself. For this, we use the throw keyword with a new error object. For instance, if a function receives invalid input, you can throw new error invalid arguments. This immediately stops the current execution flow and bubbles up the call stack until it's caught by a try-catch block. This is how you proactively create and signal synchronous errors in your application. But this simple model breaks in the async world. Now for the classic Node.js pitfall. A standard try-catch block does not work for asynchronous callbacks. Why? The try block executes and finishes, and its context is removed from the call stack. The asynchronous operation, like a set timeout, continues in the background. When the callback is finally invoked and the error occurs, the catch block is long gone. The error has nowhere to go, resulting in an unhandled exception and a process crash. To solve this, the early Node.js community established the error-first callback pattern. By convention, the first argument to any callback function is reserved for an error object. If the operation succeeds, this argument is null. If it fails, it contains an error object. This pattern forces you to explicitly check for an error every time. But as applications grew, it led to its own infamous problem. Nesting many error-first callbacks created what's known as callback hell, or the pyramid of doom, deeply indented, hard-to-read code that is difficult to maintain. To escape this, promises were introduced. A promise is an object that represents the eventual result of an async operation. Instead of nesting, you can chain operations, handling all successes with .then and, crucially, all errors in a single clean catch block. The real magic of promises is how errors propagate. If you have a chain of .then blocks and an error occurs in any one of them, the chain is broken. Execution skips all subsequent .then blocks and jumps directly to the nearest .catch handler down the chain. This allows you to have one consolidated error handler for an entire sequence of asynchronous steps, dramatically simplifying your logic. Building upon promises, JavaScript introduced async await. This is syntactic sugar that lets you write asynchronous code that looks and behaves like synchronous code. By marking a function with the async keyword, you can use the await keyword to pause execution until a promise settles. And the best part? This brings us full circle, allowing us to use our old friend try-catch for asynchronous code. With async/await, error handling becomes incredibly intuitive. You simply wrap your await calls in a try-catch block. If an awaited promise rejects, it's treated just like a synchronous throw. Execution immediately jumps to the catch block. This powerful combination gives us the readability of synchronous error handling with the non-blocking benefits of asynchronous operations, and is the recommended approach for all modern Node.js applications. As your application scales, simply catching a generic error is not enough. You need to know what kind of error occurred to respond appropriately. Was it not found or unauthorized? We solve this by creating custom error classes that extend the base error class. This allows us to add important context, like an HTTP status code or an error code, creating a clear, self-documenting error system. Now, with our custom error classes, we can make our catch blocks much more intelligent. Using the instance of operator, we can check the specific type of error that was caught and take different actions. If it's a not found error, send a 404 response. If it's a validation error, send a 400. For any other unexpected error, we can fall back to a generic 500 error. This makes our handling logic precise and robust. Let's see how to apply this at scale in an Express app. In a web framework like Express.js, littering every route with try-catch blocks is repetitive and inefficient. Instead, we can centralize our logic. Express allows for a special type of error handling middleware, a function that accepts 4 arguments: err, rec, res, and next. When you call next err from any route, Express skips all other middleware and jumps directly to this central handler. This centralized middleware is the perfect place to use our instance of logic. Here, you can inspect the error, set the appropriate HTTP status code based on its type, and send a consistently formatted JSON response to the client. This single function becomes the gatekeeper for all errors in your API, ensuring predictable behavior and making your API much easier for clients to consume. But what happens if an error occurs that you didn't expect and fails to be caught anywhere? For these nightmare scenarios, Node.js provides global safety nets on the process object. Process.onUncaught exception catches synchronous errors that slip through, and process.onUnhandled rejection catches promises that reject without a .catch handler. These are your absolute last resort. When a global handler is triggered, your application is in an unknown, potentially corrupted state. Continuing to run is dangerous. The universally accepted best practice is the log and die strategy. Inside the handler, you must synchronously log the error with as much detail as possible, perform any immediate cleanup, and then gracefully shut down the process using process.exit1. Anything less risks unpredictable behavior. The log and die strategy only works if something is there to restart your application. This is the job of a process manager, like PM2 or NodeMon. These tools monitor your application, and if the process exits, as it should after an uncaught exception, the process manager will automatically restart it, ensuring high availability. This combination of graceful shutdown and automatic restart is the key to building self-healing systems. We've emphasized logging, but in production, console.log is not enough. You need structured logging. Use a dedicated library like Pinot or Winston to output logs as JSON. These logs should include a timestamp, a severity level, the full error stack, and crucial application context like a request ID or user ID. This makes your logs machine-readable and searchable, which is critical for debugging complex production issues. Let's bring everything together into a final checklist for resilient applications. 1. Use async await with try-catch for all async logic. 2. Create specific custom error classes. 3. Centralize error handling in your web server. 4. Implement global handlers to log and die as a last resort. And 5. Use structured, contextual logging for everything. Following these principles is the path to truly professional Node.js development. You've made it! We've journeyed from the fundamental why of error handling in Node.js through the evolution of patterns from callbacks to async await, and finally to the production-grade practices that define resilient applications. By implementing these strategies, you are now equipped to build systems that don't just work, but that can gracefully handle the inevitable failures of the real world. Thank you for watching, and happy coding!